How's it going? We're doing number 22 on WebAssign now. A 1.85 times 10 to the third kilogram car, M, has a speed of VI of 13 meters a second. The car then hits a tree. The tree doesn't move and the car comes to rest, as shown in figure 11.19. Assume that air resistance is negligible. How's it going, guys? So, I wrote our givens. We have our mass and we have our initial velocity. And I wanted to discuss that whenever V is written in these types of questions, right? The kinetic energy is 1/2 mv squared and momentum is equal to mv. V is short for Vf minus Vi. That is the final velocity minus the initial velocity. Right? Because the final velocity minus the initial velocity is going to give us the total velocity. Or the average velocity, you could say. Right? So, the final velocity of this equation is 0. Why? Because it hits a tree, stops dead in its tracks. It didn't move. It's not moving anymore. Vi is 13 meters a second. So, our average velocity is actually going to be negative 13. And that's why I'm plugging in negative 13 here in this equation. Right? So that was just like a reasoning as to why it's going to be negative 13. Now, in this equation, because the negative 13 is squared, it really doesn't matter if you put what sign you put there. But for momentum, it would matter. So that's why I mentioned that. If you guys were confused on the momentum questions when I did them earlier, right? So I do negative 13 squared times 1.85 e to the third. Oh, and excuse any background noise that might occur. So the kinetic energy is negative 156,325 joules. So that's the answer for part A, which was find the kinetic energy of the car. Answer for part B is find the amount of work done as the front of the car crashes into the tree. Now this is more a reasoning type question, right? Then this doesn't involve a lot of math, this is more reasoning. Now work is equal to force times distance as shown over there. Now the force that's exerted on the force that's exerted is positive. Because the car is the one that is moving. Right? The tree is not exerting a force. It is exerting a force on the car, but it's not exerting a negative force on the car. The car is the one exerting the main force. So we're going to look at that. And the distance that the car is moving, right? We're going to assume that the distance to the right is not negative. So the distance is also positive. And due to that, the work has to be positive. And in this equation, kinetic energy is equal to work. So the work is going to be 156,325, 156,025 joules. But it's not going to be negative. It's going to be positive. That's going to be your answer for part B. Because we're looking at the force that the car is doing. The car is the main thing that we're looking at. Find the amount of work done as the front of the car crashes into the tree. We're looking at the amount of work done by the car. The car is doing a positive force, and it's going in a positive direction. It's moving in a positive distance as well. That's going to be the answer for part B. Part C is find the size of the force that pushed on the front of the car by 50 centimeters. Now you're going to do work is equal to force times distance. 156 times 325. 156,325 joules. Wow, these are some goofy numbers, let me tell you. By that I mean my handwriting, not the actual numbers. But force times distance, which is 0.50 meters. Now, why did I do why did I convert it into meters? Because in physics, or basically any science class, you want to convert stuff into meters a second, kilograms, into standard units, right? And the way I converted centimeters to meters is I did 50.0 centimeters times 100 centimeters times 1 meter. And that's how I got 0.50 meters. Right? You can double check that if you want. 50 divided by 100, 0.50 meters. Now I'm going to plug that into my question. 0.156325 joules divided by 0.50 meters is equal to, already here, 312,650 newtons. Force is in newtons. Right? And always remember to place the unit afterwards. The WebAssign does it automatically, but you know, in a real physics question, you gotta write newtons, or your teacher might mark it off if she's, you know, strict. And that's gonna be your answer for part C. This was your answer for part B. This is your answer for part A. So let me write that down. A, B, C. That's how you do number 22 on the WebAssign.